Well, being in an embedded Linux, you would have obviously come across the terminologies like Yocto, the build root, and any other build system as well as such. So, have you wondered what these things are? What purpose do these things, Yocto, build root, and all serve? So, actually speaking, all these things are the build system. This is what today's video is regarding. So let's right away jump into this topic of build system. Hi everyone, I am Pradeep Tewani. I am a trainer and consultant. To know more about me and the courses which I offer, refer the description. Let's now right away jump into this topic of build systems. So first of all, we need to understand why do we require this build system and what actually this build system are. What value add do they provide and why everyone looks for the build systems. So first of all, we need to understand that embedded Linux system typically comprises of five different components. Now, what are these five components? The first component is obviously what we call it as a toolchain. Now, what is toolchain? Toolchain is nothing but the collection of tools which allow you to generate the binary from the high level code such as C code. Toolchain, typically in the embedded systems, we use it as a cross toolchain. What do I mean by cross toolchain is you execute the toolchain, say on x86 platform, but whatever output, whatever binaries it generates, it's supposed to be executed on the target platform. Next component which we have got, and it's very important, is something called the bootloaders. Now, what is bootloader? As the name itself suggests, bootloader means something which allows us to boot up the system. So some piece of code which runs immediately as soon as the system is powered up. So we have the bootloaders like U-boot, Red boot, and all those things are the second stage bootloaders. And then we have the typically the first stage bootloaders as well. Next component which you have over here is something called kernel. Now, what is kernel? In simple terminology, I can say kernel is the one which manages the system resources. So we have got five different resources as such. Accordingly, we have five different tasks which kernel does. So these are basically the process management, IO management, network management, storage management, and memory management. So the one which does all these five things is what we call it as a kernel, the operating system. The fourth thing which we have got is, of course, the root file system. Now, what is root file system? In simple terminology, I would like to say root file system is the one which allows you to allows the normal user to work on the system. For example, as a normal user, what do we require is basically some set of commands. What do we require is and for the commands, of course, what you will be needing is the libraries, and then you would have a variety of application where the libraries would be needed. So basically a directory structure which is mounted on the slash and something which contains all the basic utilities, at least for a for a user to work on the system. That's what is the root file system. And last but not least is what you have got is the application. So typically your embedded Linux system is comprised of these five components: the toolchain, the bootloader, the kernel, root file system, and the application. Now, here here comes the challenge. What happens is when you will be dealing with this embedded Linux system, one of the way which is available to you is uh, have all these components being compiled and maintained separately. That means you can download the toolchain, say from Linaro, then you can have the bootloaders from the of course the DAS U-boot, and then you can have a kernel from kernel.org, and then you can build the root file system of your own. And application typically are the proprietary application. There are also the third party applications available as well. So the key thing which you need to understand is all these components come from the different sources. And now what you need to do is you need to combine them together. You need to bring all of these things together to make a embedded Linux system work. And that's where the challenge begins, where you basically need to make all these things work, though they are coming from the different uh, sources, different communities. And now what happens is, one of the biggest challenge which you will face is the inter-package dependencies. Let's say you have the GCC, you have the glibc, these versions which you have got, they are not matching with each other. So what will happen is, there are chances that it may break. And let's say you are using a kernel version which is of like higher, which is of latest like 6.67, something like that. And then what you have got is, like, you have got the U-boot which is of the older version. So typically there might be some mismatch. So these are the biggest challenges which we face when we deal with these components separately and we want to bring up the whole embedded Linux system. And this is where what you need is something called integrator, something which can really integrate all these things together for you and can give you the complete image which works. That's what the build systems do. So now that we understand what the build system is, let's now understand the working principle of the build system. How does the typical build system works? Now, if you ask me, everything just boils down to something like how a typical open source package is being built. So what typical steps you do with open source packages? First of all, you will be downloading it, then you will be unpacking it, then you will be configuring it, you will be patching it, and finally you will be building it and installing it. So every open source package typically goes through all these stages. So build system will typically be doing all these things with the help of the scripts in the automated manner, so that it can give you the complete image, and you don't have to deal at the you don't have to basically individually build these components. So what you do is, you will get the build system, say any of the build systems such as Buildroot or Yocto, and this particular build system, what you have got, you will be configuring it for the target platform. Let's say I want to build it for the BeagleBone Black. So I will do all the configuration for the BeagleBone Black. Let's say what kernel version I want, what bootloader I want. All these customizations can be done with this build system. So based on the configuration which you have provided, what build system will do is, it will try to fetch the packages. It will try to it will try to fetch the source from the any of the resources which are available upstream. So it can be based out of HTTP, FTP, JIT, SVN. So wherever those resources are being maintained, it will try to fetch it. Apart from this, you might have to also give your local resources which might be available with you. So in-house components which you might be having and you would like to provide as an input to the build system, you can do so. So these things are being fed to the build system. Now, build system, with the help of some scripts, some make files, or whatever may be the framework it is working on. Typically, Yocto works on the recipes and the Python-based BitBix system. So it will try to fetch all these things, then it will try to configure it, it will try to patch, it will basically then build it, and it will install. And at the output, what you are going to get is these 5 components. The first thing, of course, which we need is a tool chain. Next, you get the bootloader images, you get the kernel image, and then you get the root file system. Now, build system typically provides you the feature by which you can have a single image generated, which consists of these 4 things all together in a single package, and you get a complete image, and that you can flash it onto your whatever SD card or whatever flash memory you might be having. So this is the working principle of the build system. Now that we understand how does the build system works, let's now move on to what all different popular build systems we have. So first of all, what you have got, and it's very common, is like a build root. Another one is what you have got is the Yocto project. Apart from this, there are various other build systems. You might say PTX dist and all those things, but they are not that popular. And Buildroot and Yocto are typically most popularly used everywhere. Now, what is this? What are the advantages of this Buildroot? So if you ask me, Buildroot is very simple, efficient, and easy to use tool. It just comprises of a normal makefile and the scripts to generate the images. Now, if you look into the Yocto, Yocto is basically the collaboration project where big players like Intel, Qualcomm, all of those players came together and they wanted to have some working system, and the life of the embedded Linux developers should be kind of smooth. So that's where they started with this project where they came up with a working configuration which should work for any of the machine when you will be configuring it. So it's a collection of recipes, the configuration values and dependencies used to create the custom Linux image. Now, if you see Buildroot, the advantages of the Buildroot is it's simple to use, generally produces the smallest possible image. But the disadvantage of the build root is any changes in the system configuration files requires a full rebuild of all the packages. Intermediate package state caching is not being enabled over here. So if you do any changes, the whole package would be rebuilt, something like that. But if you look into the Yocto, it's extremely flexible and customizable. It has got the modularity and the reusability, intermediate package caching so that your build is speed up. So if you are building it for the second time, it's like it should be very, very fast. But the disadvantages of the Yocto is steep learning curve. Typically, the terminologies and the terms, if you want to get used to it, you need to be very dedicated and you typically need to practice a lot. But once practiced, it's worth spending every time on any of the time which you have spent on the Yocto project. So another thing is like build time. Typically, when you build it for the first time, depending on the machine, it might take 8 to 10 hours, and the resources are fairly high. Typically, you might be needing 60 GB, 80 GB, something like that for the build to have. So to summarize, embedded Linux system as such consists of 5 different components: toolchain, the bootloader, the kernel, the root file system, and the application. And all these components typically come from the different communities. So when we are dealing with these components individually, one of the challenge which we face is the inter-package dependency, where because of the inter-package dependencies, you might hit some issues and probably your system might break. So what we are looking for is something which can integrate all these components together for us, and the maintainability is a smoother task when we are dealing with all these embedded Linux components. That is what the build root does. So typically two types of build roots which we have. So two types of, that's where we basically need the build system. So two types of build systems which we have typically is the Yocto project and the build root. Hope this clarifies all your queries related to the build systems, and now you are very clear about what the build root is and what the Yocto is and what roles they have to play. For more such videos, subscribe to my YouTube channel and also write down in the comment box what all topics you would uh, like me to cover the videos for, so that I can prepare them accordingly. Okay, so till then, stay tuned. Bye bye. Thank you very much. Bless you.